Here we are, all the steels are in now. There's been some adjustments that have been made, shimmed out of the top, so they're sitting better on the pad stones. Before they were slightly sort of inward, so as I say, steel installers have packed them out of the top, which has brought them, it's given them more central bearing on the pad stones. So what we're going to do now is set a temporary handrail up around where we've fitted our staircase, to make that nice and safe. We've got the sole plates down for the ashlar wall. Building's nice and parallel. So we're going to start moving all these loose sheets, laying our sole plates for the rest of the stubwork, so forming the 2 bedrooms, ensuite area, large family bathroom, mark out our stud locations, and then we just need to get confirmation from the main contractor on how much floor we can lay, because obviously there's still got to be plumbing and electric still running the floor. So we might be able to lay some floor in, leave a gap, especially in the used area. They can pull their pipes and cables through then. Once they've done that, then we can fully floor the area, giving us a nice, solid working deck. We've blocked out the steels, ready for fixing our rafters in to form the dormers. So these steel locations are basically showing where the dormer's going. We've got 2 at the front, as you can see there, and 3 at the back there. Yeah, so once we've got the floor sorted, sole plates down, then we'll start building the ashlar support walls front and back, and then we'll start pitching off our rafters. Right, so we're just getting our height of our ashlar support wall now. So it's going to be, we're going to bird's mouth the rafters on top of it to give a good bearing location. So how we work it out, I've clamped a bit of timber on there, 9x2. So I've gone 12mm above the steel, which is generally the minimum to allow for deflection. So in time settlement, like the weight of the tiles, etc., can push it in. If you had less, you could have a hump in the roof from the steel. So I've got 6mm underneath. Right. Plumbing up in the front of the wall. That's giving us this line here. Plumb up the back. So this here is our wall, front and back of the wall. So the pitch is 45 degrees. So now come in a third of the timber, which is 73.3. Like that. That's the C cut. That's the plumb cut, the bird's mouth. So if I now measure off this sole plate to that line, 1.16 or minus 90mm, which is the size of a double top plate, which you have to have if it's load bearing, and that'll give us the length of all our studs. So these joists have been laid, then we cut them all the same, and yeah. So we're at the stage now of setting out our rafters. So the steel structure isn't quite parallel or level and plumb. So what we've done is we've put a couple of dummy rafters up. So we've got a third of the timber, which is a 9x2, third is 73mm. So we put one down there, which is sticking above 10mm, but it's a bit below, which means the battens on the roof can sail over, and the insulation plasterboard can sail underneath. But the issue we've got is some of these steels where you've got a slight upstand where the pad stone is, over at that end, they're set further in than these. So the knock-on effect that has is to keep the same height of our plate at the bottom. We know this is level, this ring ring, so we lasered it with a rotary laser. Yeah, to keep the same height of our plate, it sits higher above the steel, about 25mm. So what that means is it sits in with the inside of the building. We've confirmed with the contractor they're happy to counter batten the inside to get over that, because you don't want to end up too flush. You know, like if you end up flush on the outside, you'll have to counter batten the outside, because of deflection it could form a hump in the roof. But yeah, they're happy to counter batten the inside, which is fine. But then we've lasered the cranked ridge beam end to end, it's only 6 mil out of level, which isn't too bad. That end is 15 mil off centre. This end's 6 mil off centre. So, and then there's a bit of a hump in the middle. So, to try and get happy medium, we're keeping the rafters equal distance above the steel at this end. Same at that end. It's higher that end, obviously, because the steels are sat in further. But what it means is the height of our plate, which is a vertical point from the bird's mouth intersection of the seat and plumb cut to the top here, is different all the way along here. So we've pulled a string line with tension. We've had to measure every single height of our plate where the rafters are going to land on this Ashlar support wall. So we'll have to cut them all individually. We can't just use, we can use a pattern for the foot, but not for the length. Same with the top rafters. The bird's mouth is bigger this end than it is that end. And our apex, because the steels are setting further at that end, means the apex is sort of further out of level by about 30 mil. But our way of getting around that is the apex will be kept at a point at this end, and at that end we'll set a laser and we'll cut the apex flat. But when the ridge tile goes on, you've got about 70 mil clearance from the sort of half dome, if you like, of the ridge tile. So if it's dry fixed, when they dry fix into the flat part, it's going to keep it all level, so the batten gauge won't change. Or even if it's mucked on, as long as they're going to a flat surface, it's never going to be noticed. So that was our sort of happy medium that we've got. Otherwise, to get the ridge dead level, the distance we've got above over there, which is 25 mil, it'll be almost flush, if not inset at the top at that end. So, as I say, when something's not quite square, parallel, plumb and level, you've got to make a happy medium and go from there. So here's how I'm getting all the measurements for the top common rafters. As I was saying before, the ridge is out of level and the centre is off centre. So the centre line, true centre of these is off centre to this. So I've adjusted the first one, we've got that one in, sitting parallel above the steel, and it's not in the centre of this beam, but this plumb cut is in the centre of the building. We've got this one in, we've got one in over there, which is in the centre. Oh, it's 3 mil off actually, 3 mil over the centre to the left. So yeah, the height of our plate there, pulled a line from that end to here, and then I've got another line on the face of the plumb cut. As I say, it's off centre to the steel, all the way, again, what we call a dummy rafter, which is a representation of what the true full length rafter is going to be. That, they're my reference points now. So where the cranks are, I'm measuring up vertically to the string at the location of each crank, and then I'm paralleling from where we're bolting the timber within the ridge beam to that string, and they're different, as I say, all the way along, but that will keep the roof nicely in plane. So here's one of our completed barn ends, barn hip ends. The wall plate we had to pack up temporarily because the internal block work is a bit low, so they're going to have to fill that in, and those temporary blocks can come out. Just meant we could carry on, get the roof pitched up. A little bit tricky getting the position of these hips. As you can see on the left side there, we've got the hips splaying onto that common rafter that we've nailed to the side of the crank steel. And then this side we've got the hip bird's mouthed on top of the ridge beam of the crank steel. So we cut a couple of templates, one at the top, one at the bottom, and then measured from the bird's mouth down to the load bearing bird's mouth at the bottom here on the wall plate. And then the other thing with this was we paralleled off to allow this to be 45 degrees, same measurement. But then to try and achieve the height above plate to get above the steel and plane it in this side, we've had to slide the hip round slightly. You can see I've got a couple of pencil marks there where I've levelled from the top of this wall plate to give the seat cut line, plumbed down and paralleled to give the height above plate line, one on the right hand side there. That was 170mm. But to get above the steel it had to be 210. So as I say, we had to slide this round for it to meet 170 to plane through there as it does. And it's kept it above the steel this side. So I'll just show you the other side now. So that's the main structure completed now, other than the dormers. All the eaves are cut and prepped ready for fascia and soffit. Stud work's all done on the inside. Flooring's still loosely laid because the services aren't completed yet. I'll just give you a quick walk around, show you how we're looking. You can see there's 2 dormers at the front, 3 at the back, 3 Veluxes at the front, 1 in the stairwell, 1 in the main bathroom, 1 in the ensuite. So there you have it. Next video I'll be showing the dormer construction and then a walk around of the full job, fully completed. Thanks for watching.